Welcome to our mathematics class, and we are continuing with number and algebra, and today I want us to look at computation with decimals. Computation with decimals. We've seen earlier on the computation with fractions, how to add, subtract, multiply, and divide. This time round, we want to look at decimals. We say decimal forms part of a whole. When we are dealing with the decimals, how are we going to add them up? How are we supposed to subtract them up, multiply, and finally divide decimals? Decimals are simply easier to handle, especially when you are dealing with those numbers, with the decimals being handled with the same number of decimal places, or same number of the decimal places when you are adding. Now, I want us to look at what is it that we are calling a decimal place. If I have a number like 2.35, this is a whole number part, and the 0.35 is the decimal part. So, to add and subtract numbers with decimals, it is important that we observe what we learned earlier about the place values. Those numbers with the same place value are placed in the same column before you add or you subtract. So it is necessary for you to know that the place value of every number or digit in a decimal matters a lot, and we should know how to allocate it. For example, given what I have, this is a whole number which simply forms a unit. This one here is a decimal part, and it is the first decimal part which forms a tenth. And lastly, the last one here is a decimal part which forms the part hundredths. So we are saying that for you to add and subtract decimals, you must know what we call the place values. So for you to be able to add and subtract decimals, you must ensure that the digits are arranged correctly and aligned in similar place value columns, We need to have the second point. First is the alignment. We've said align. You align the digits so that the place values that are of the same value are placed in the same column. 2 is about aligning the decimal point. Decimal point must be lined up directly above the other one, or directly with the other one. Let us look at this and see what we are trying to say here. $37.56 plus 5.231. For us to be able to add this, we are going to arrange them in column form, and observing the rule of the place value for each digit. So that's 7.56 plus we have 3 in the column of tens. We have 7 in the column of unit. And then we have 5 in the column of tenths and 6 in the column of hundredths. Therefore, 5.231, 5 falls in a column of 1, so it will be directly below 7. Then the decimal point should be aligned right below the other one. And then followed by what comes here is a digit that represents a tenth. And for this case, it is 2. Followed by the digit in the column of hundredths. And this case here, it is 3. And finally, the digit in the place value of thousandths. And this case here, it is 1. Now, the space here that is left, we need to make it actually be alike, so we shall place a 0. A 0 is just insignificant when placed there because it is at the end of a digit after a decimal point. Now here, we are ready to add. We add in column form starting from the right to the left. So 0 plus 1 is 1. 6 plus 3 is 9. 5 plus 2 gives us 7. The decimal point remains again aligned the same point, so we have the decimal point coming. 7 plus 5 gives us 12, right below the same column. Carry 1. 1 plus 3 gives us 4. So we have been able to add 37.56 plus 5.231. What you should not do is as follows. Do not take that 7.56 and you add when you look at what I have, the digits in the same place value are not aligned. The decimal point for the first and the second is also not aligned. So I'm discouraging you from doing anything similar to this. So we cannot add or subtract decimals when we don't align them as per the place values. Multiplying and dividing decimals by power of 10. When we talk about power of 10, we've taken a different direction. We shall have to multiply a decimal or divide a decimal by a number that is a multiple of 10. And then later on, we look at multiplying or dividing decimals by other decimals. What rule must we observe to be able to multiply and divide decimals? Now, I want us to take a number like 100 100 is a number that is a power of 10. That is the 10 power of 2. So we want to multiply our decimal with 100 and see the behavior of the decimal point. .753 multiplied by 100. Now this one, it will happen that we shall have, let us ignore the zeros first and deal with we are going to ignore the zeros and ignore the decimal point. Then we just multiply first and then we come in and start seeing what are we supposed to do. So we shall have, that is like, we shall have 13,753, and then look at the place where the decimal point was, which is here. The place where the decimal point was, when we multiply by 100, the decimal point will move to the right how many times? The number of zeros dictates the number of steps you will take as you move the decimal point to the right. So this is 1 and then 2. So the decimal point will move from being between 3 and 7 to be between 5 and 3. That becomes, so the product of this question here becomes 1375.3. So we are saying this. The number that you are multiplying with dictates the number of steps you will take to the right when you are multiplying any decimal with a number of power of 10. Let us take another number. This is 4.721 multiplied by 10. How many zeros does 10 have? It's only 1 0. If it is 1 0, then we expect that this decimal point will move how many steps to the right? 1 step. So I'll have it 4.721, and the decimal point moves from here to this point. So we shall have our answer as 47.21. 47.21. That is, we have been able to move the decimal point to the right. If we have a pure decimal like 0.7512 multiplied by 1,000. So this one you'll have it as 0.7512, and then the decimal point will move. The number of zeros is 3, so we shall move 1, 2, 3, and that is where we shall stop. A 0 before the digit is also insignificant, so we shall have our solution here as 751.2. That is if we are multiplying a pure or proper decimal with a number to the power of 10. How about when we are dividing? We are going to consider the power of 10 still. When dividing the decimals, the power, when dividing the decimals with the power of 10, the decimal point appears to move this time to the left. When you are multiplying, it moves to the right. But when you are dividing, it will tend to move to the left. How many steps, and how do we know the number of steps we shall move the decimal point to the left? You look at that number you are multiplying with, the number of which is the power of 10. If it is only 10 with 1 0, we move to the left 1 step. If it is 1,000, we move to the left 3 steps because 1,000 has got 3 good. 1,000 has 3 zeros. So the number of zeros dictates how many steps you're going to make. So we have 5.73 divided by 10. We are looking at 10. So we are to find out how many steps, as you have seen, it should move to the left. So how many steps will decimal point move? So we shall come and have 5.73, and then we move the decimal point to the left by the number of zeros, which is 1. So it will be moved to this part. We put a decimal there and bring in a 0, so that our solution here becomes 0.573. 0.573. 586.92 divided by 100. 100 has got 2 zeros, so the number of decimal places you will move to the left is 2. So this one will be 586.92. Then we move the decimal place 1, 2, because we are dividing by 100. So the new location of the decimal point will be there, and then the answer becomes 5.8692. That is it when you are multiplying and dividing the numbers with the power of 10. How about when we are now dealing decimals to decimals? Now, when multiplying decimals alone, point number 1, ignore the decimal points and carry out the multiplication just as ordinary multiplication of integers. I've said, in multiplying decimals, ignore the decimal places and carry out the multiplication in the ordinary manner. And also, the decimal now, I want to say before I work out this, the position of the decimal point in your answer will be determined by the rule. It's not by just an observation. Its position will be determined by the following rule. the number of decimal places, the total number of decimal places between the two decimals that you are multiplying makes the total number of decimal places in the answer. So we need to know that we shall only locate our decimal point after counting the total number of decimal places from the far right towards the left. So when you look at this, say the first thing you do here, we are going to ignore the decimals. If you ignore the decimals, you'll have that is the multiplication. We are multiplying. You can use a calculator, you can use whatever gadgets you have, as long as you come up with the correct answer. And when you multiply that, you'll get 49,278. Does this number has decimal places? At the moment, no. But the question we had, what? Decimals. So we are saying the location of the decimals in the answer is determined by the rule that says it should be equal to the total number of decimals that both the numbers being multiplied together add up to. So the number of decimals in the first one is 2, and in the second one is 1. So 2 decimals plus 1 decimal gives us 3 decimal places. So from the far right, coming to the left, start counting the number of decimal places. So from here we shall count 1, 2, 3. Put a decimal point there. So our decimal is now complete in multiplication, and we have 49.278. 49.278. So how many decimal places are here? 3. What is the total number of decimals in our question? 3. Then we place our decimal point. There is no relationship between a direct relation that we have to place it below or above. No. Carry out the multiplication in a usual way, count the number of decimal places, and place it there. What happens when we are dividing? What happens when we are dividing decimals? When dividing decimals by other decimals, when dividing decimals by other decimals, when dividing decimal point in the quotient goes directly above decimal point in the dividend. For example, 56.34 divided by 3. 56.34 divided by 3. Now, to divide this, we do it in a simple way. We start dividing from the way we know from we take what we call the dividend, and from this one we start with 5. 5 divided by 3 gives us 1. then 1 multiplied by 3 gives us 3. You subtract, you remain with 2, you bring 6. 26 divided by 3 is 8. Right there, 8. 8 gives us 24. When you subtract, you remain with 2. You do not need to bring the decimal point. We are interested in the digits, but we are saying the decimal point comes directly above the, that is the dividend. So at this point, we expect the decimal point to come right above this, which is there. So when we bring 3 down, then 23 divided by 3 gives us 7, which is 21, remaining 2. That is, we have 14. 23 minus 21 is simply 2. So bring in 4 to be 24. Divide by 3 is 8. And this one gives us 24. This one here is called quotient. This one here is what we call dividend. And this one, 3, is what we call divisor. So we are able to identify the dividend, the divisor, and the quotient. This quotient is our answer. It is the answer we are looking for. That's what we are calling the quotient. So if you look at the behavior of the decimal point between the quotient and the dividend, it is directly above the decimal point of the dividend. That is the relationship while we are dividing decimals. There is a situation when you are dividing decimals with other decimals. In mathematics, some things we do them logically. If you are dividing a decimal and a decimal, we always avoid that by simply seeing how well to make that divisor to be a number that can be easily going to be divided. When you are dividing a decimal and another decimal, change the divisor into a whole number. It's advisable you change the divisor into a whole number. Now, take for example, (27.354) divided by 0.02. So we need to know that this is just the same as rewriting this like a fraction, like that is 27.354 divided by or over 0.02. We are saying try to find a way and make sure that this denominator here or this divisor here is a whole number. And what happens here is that whatever we will do to make this one a whole number should be done on the dividend also. Whatever you do to this denominator should be done to the numerator. So for us to make this a whole number, you'll notice that I'll need to multiply by what? 100, so that I move 1, 2 decimal points. So multiply this by 100. Multiply this one also by 100. If you are using the fractions type, multiply this by 100, multiply down by 100. When you are multiplying, decimal point moves to the right. The number of steps is equivalent to the number of zeros that we have. So we can go ahead and now see this 27.354 multiplied by 100, it will move 1 step, 2 steps. So we shall have 2735.4 divided by, when it moves 2 steps, it becomes 2. So this time it is easier to simplify. If you had used here, you realize that you have 2735.4 over 2. You can cancel or simplify where possible and still remain with the same answer that we want. So this one you can divide using either long method or simply go in by short method, where 2 by 2 is 1, 7 by 2 is 3, carry 1, 13 by 2 will give us 6 because of 12, carry 1, 15 by 2 gives us 7, carry 1, 14 by 2 gives us 7. So we are able to divide. If you are to cancel here again, we'll say by 2 here is 1, 3, we have 6, we have 6 here, combined 1, 15, we have 7.7. So this one is 136.7. So you can always solve by simply making the divisor to be a whole number. So that is it, how we work on the decimals and when we are multiplying decimals and when we are also dividing decimals. Let us look at workable examples and see how we are going to apply the knowledge that we've gone through. We have 23.07 plus 103.65. 23.07 plus 103.659 plus 9.9, and B we have 9.7 minus 2.86. We said for us to be able to add and subtract, we shall arrange these numbers. The digits we should be placed below each other of the same place value, same to the decimal point. So to rearrange, we have 23.07. Then we go all the ones, all the ones, that is the units, all the tens, hundreds should follow like that. So from this, you realize this is our ones, tens, and hundreds. So ones will come here, tens will come here, and 100 will come along there. Then moving this other side, this is tenth, then hundredths, and then thousand. So it will make us add a 0 on the far right of our first number or first decimal. Then we are going to add 9.9. 9 is a unit place value, so we place 9 here, and this is a tenth. This is what we have, and then we add. Very, very important that with these spaces we can fill with the zeros and to maintain the place value for each and every digit. Addition is done from the left coming to the, from the right coming to the left as you follow the column. You exhaust the column before you move to another one. 0 plus 9 plus 0 will give us 9. Did we carry any number? No. 7 plus 5 is 12. And we've carried a what? A 1. 1 plus 6 plus 7. This one gives us 16. We write 6. Decimal should follow here, but we carry 1 because of 16. 1 plus 3 plus 3 plus 9 gives us 16. That is 4, 7, and then 16, carry 1. 1 comes there. 1 plus 2 plus 0 is simply 3. This one has got no partner. We just write it down as 1. So this is simple evaluation or simple answer when we add these decimals. This is what you get. For question 2, we again rearrange. 9, its place value is ones. 7, its place value is tenths. Minus 2 is under 1. Then we have 8, which is under tenths, and then we have 6. We are subtracting, so we bring in a 0 here so that we can be able to have the columns for all the areas we require. 0 minus 6, we don't know, you cannot write here minus 6 here. Something odd. So there is something we say, borrow from the next column. The next column to this one is the next immediate column to the left. When you're subtracting a number less than itself, then we shall be required to borrow from the next column to the left. And what we borrow carries a certain weight of a multiple of, I'll say it carries a weight of a whole 10, because we are borrowing here, it's 1. But when 1 is brought here, it is the same as 1 multiplied by 10. So this one will be 10. So borrow 1 here. 7 minus 1, what is remaining here is 6. So this one is now 10 minus 6, which is 4. This one we don't have 7 anymore, but we have what? 6. 6 minus 8 is again another issue. We move further to the left and ask for assistance. We borrow again from the next one. So we shall borrow 1, and what remains here is 8. So when you borrow this one, when it comes here, we don't add it to 6, but it is carrying a weight of 10, so it will be the same as 10 plus 6, which is 16. So this one becomes 16 minus 8, which is 8. What we have here is not 9, but it is what? 8. So 8 minus 2 is 6. 8 minus 2 is 6. So you find that our answer there is 6.84. Calculate 9.753 753 divided by 100. We are dividing. And this one, 27.58 multiplied by 10,000. The rule says when you are dividing by the power of 10, we look at the number of zeros and we shall move the decimal point. The number of steps are dictated by these zeros to the left. So for this case here, it is the same as 9.753 over 100. If that is the case, This one we need to move to the left how many decimal places? 2. So this is 9.753, and then we move to the left because we are dividing, move the first time and move the second time. So this one becomes the 0.09753. That one will be our new value for this when you divide. This one, other side, we are multiplying. So when multiplying, we said we count the number of zeros and we move the decimal point to the right. And the number of steps we shall move is determined by the number of zeros. So this one is the same as 27.58. And then we shall move how many decimal places? This is 1, 2, 3, 4. So it becomes 275,800, 275,800. 275,800 is now a whole number. So we should be able to simply multiply a decimal and a power of 10. (2.57) multiplied by 3, and we have 4.13 multiplied by 96. Multiplied by 96. Starting from the first one here, we said we can always assume what? We can always assume the decimal point, we multiply, and then we now count the number of decimal points that was there between the multipliers, and we bring them together as we count for the number of decimals in the answer. So this case, as we ignore the decimal point first, you will carry out the multiplication in that way, a simple way. And when you multiply this, 7 times 3 is 21, carry 2, 5 times 3 is 15, plus 2 gives us 17, and 2 times 3 is 6, plus 1 gives us 7. Then we look at what was the total number of decimal places. Total number of decimal places in our product was 2. So we shall count 1, 2. We have our decimal place there. So our answer becomes 7.71. This one is our solution. This one is our solution, 7.71. The other side, we are trying to multiply a decimal and a decimal. I said earlier on, when you are multiplying two decimals, in mathematics, it is normally not encouraged. It's always not encouraged to maintain the position of the decimal point, but instead we ignore the decimal points, we multiply the numbers, and then we come to the answer and count the number of decimal places that the multipliers were adding up to. So in this particular case, we are going to ignore the decimal places and multiply 413 multiplied by 96. You can always use any method you are comfortable with. You can use a long method, you can use a short method. Now, for this particular case, we can be able to multiply this and then put in mind that the sum, total number of decimal places, in this case is 3. So when we finish our multiplication, we should get what? We should count the 3 decimal places. So this one will give us 3 by 9 gives us 27. And then this is 9 by 1 is 9 plus 2 gives us 11. Carry 1. 9 times 4 is 36. Plus 1 is 37. This other part, it is 3 times 6, which is 18. Carry 1. 6 times 1 is 6 plus 1 is 7. 6 times 4 is 24. Nothing carried, so we have 24 here. This space here on the far right, we can have a 0, and then we do our addition. When you add this, you'll find this is 8, 14 carry 1, 5 plus 1 is 6. This one is 9, 3. So we have the figure as 39,648. Is this our answer? Definitely not, because we were multiplying decimals. So can we go ahead and count the number of decimal places that we have so that we can have a valid answer? We have already noted that the total number of decimal places in our question was 3. So from the far right, we start counting. This is 1, 2, 3. We shall have our decimal point there. Don't count from the left to the right, but from the far right to the left. So we find that our answer is 39.648. Let us now look at dividing decimals with numbers and decimals with decimals. First question is asking us to divide 35.756 divided by 4. And second one is 64.137 divided by 0.003. Now here we said we have the relationship of the decimal point between the quotient that you get, which is the answer, and the dividend. Forget about the divisor. So for this case, we shall rearrange it, and we have we are dividing by 4. So because 3 cannot divide into 4, we move the next step to 35, and 35 into 4, you'll find it is 8. 8 by 4 is 32. When you subtract, what you get is simply 3. You'll bring in after the decimal point, what you have is what? Is 7. So the decimal point here will remain because it should be strictly above the dividend. So that 7 divided by 4 will give us 9, which is 9 by 4 is 36. When you subtract, you find you have 1 remaining. And then you'll be forced to bring in 5. 15 by 4 is 3, which gives us 12. We shall remain with 3. Bring in 6, and 6 will give us 9. 9 by 4 is 36. When you subtract, it's done. So we brought 7 down, we brought 5, we brought 6. We are concerned about the position of the decimal point between the dividend and the divisor and the quotient. And I said this quotient is the same we call our answer. So if that is the case, if we are able to identify our question, which is our answer, we can simply conclude by saying when you divide 35.756 by 4, what you get is 8.939. Lastly, this was a decimal and a whole number. This time we have decimal and decimal. In mathematics, it's always good to simplify your methods. So it's not advisable to divide decimal and decimal, but you will be required to simply reduce that divisor from being a decimal to a whole number. What is our divisor in our question? You notice that our divisor is 0.03. If it is 0.03, are we going to work out like that? No, we need to improvise. And to improvise this, we need to find what will be multiplied by this to make it a whole number. This is just the same as 64.37 over 0.03. Whatever happens on the denominator or the divisor should happen also on the numerator, which is our dividend. So for us to move to the right until we remain with 3, we realize we shall have to multiply by 100. The same should apply on the numerator. So take the numerator, also multiply by 100. Right? So when you do that, you'll find that what you are remaining with is this decimal part will move 2 steps. So the 6413.7, 6413.7, the whole of it over 3. 3 is a whole number. You can check if it is divisible, you simply cancel, or you can go the longer way and divide. Take note that the dividend and the quotient should have its decimal point aligned. So if that is what we have, then we divide 6 by 3 is 2. 2 by 3 is 6. So this one is done. We bring 4. 4 into 3 is simply 1. Carry 1, we have 1 and 1 there. Then we have 11 into 3 is 3. This one gives us 9. Remainder 2, we bring in 3. 23 into 3 will be 7 because of 21. Remainder 2. So 2, we shall have to bring 7 to be 27. Now, before anything, the decimal point should be aligned. So after the 7, we have a decimal point. 27 by 3 is simply 9. And this one gives us 27. When we subtract, it is done. So we are simply saying that our quotient, which is 2137.9, is our answer to the question 64.137 divided by 0.03. Sometimes these same decimals or fractions can be used when we are substituting values. You can be given values and then the expression is given in algebraic form. You substitute the values and you find it is in a form of adding, subtracting, multiplying decimals. Then you have to substitute correctly and work out. Looking at this, we find that we should be able to substitute even decimals given the the values of the decimals. Now, given A is 0.12, B is 2.3, and C is 3.42. Find A plus B plus C. You see, we've been given here an expression, but we have their values there. We must be able to handle it by substituting correctly. To substitute this, where we have A, put the value of A. So we can write this and say A is equivalent to 0.12 plus B, which is 2.3, plus C, which is 3.42. Now, coming to aligning the place values, you'll find that we have 0.12, then 2.3, 2 falls in the place value of ones, and 3 in place value of tens. So this one will be 2.3. We don't have anything there. You can have a 0. And then 3.42, 3 falls in the column of ones, 4 in the column of tens, and 2 there. Then we add. So by adding, 2 plus 0 plus 2 is 4. 1 plus 3 is 4. 4 plus 4 is 8. Decimal point remains aligned. Then 0 plus 2 plus 3 is 5. So we find our answer is 5.84. 5.84. So we should be able to handle any problem as much as possible, as long as we are able to reduce the problem by substituting, whether it is fractions or whether it is decimals. And when we substitute, we apply the rule of adding, subtracting, multiplying, and dividing correctly.